Welcome back, physics class. Today we're going to continue our talk about momentum, which remember, momentum is conserved for all collisions as long as external forces don't interfere. A change in momentum depends on the force that acts and the length of time it acts. If the momentum of an object changes, either the mass or the velocity change, or both. Because remember, yesterday we talked about the formula for momentum was P equals mv. The greater the force acting on an object, the greater its change in velocity, and the greater its change in momentum. A force sustained for a long time produces more change in momentum. Both force and time are important in changing an object's momentum. When you push with the same force for twice the time, you impart twice the impulse and produce twice the change in momentum. The quantity force times the time interval, or change in time, is called impulse. The greater the impulse exerted on something, the greater will be the change in momentum. Impulse is the same as a change in momentum. So you can go ahead and rewrite this equation as force times time, which is your impulse, is equal to your change in P. And remember, P is really just mass times velocity. To increase the momentum of an object, you want to apply the greatest force possible for as long as possible. A golfer teeing off and a baseball player trying for a home run do both of these things when they swing as hard as possible and follow through with their string. This increases the time that they are in contact with the ball. The force of impact on a golf ball varies throughout the duration of impact. The forces involved in impulses usually vary from instant to instant. A golf club that strikes a golf ball exerts zero force on the ball until it comes in contact with it. The force increases rapidly as the ball becomes distorted. The force diminishes as the ball comes up to speed and returns to its original shape. We can use the average force to solve for the impulse of an object. Let's talk about decreasing momentum for a moment. If you were in a car that was out of control and had to choose between hitting a haystack or a concrete wall, you would probably choose the haystack. Physics is going to help you understand why hitting this haystack would be entirely different from hitting a concrete wall. If the change in momentum occurs over a long time, the force of impact is small. Let's take an example. Say that your change in momentum is 10. This is equal to some force times its change in time. Let's call our time also 10 seconds. So you have momentum, which is equal to 10, times a force times 10. Divide them both by 10. Your force would be equal to 1. Now, let's take another example. Let's say this time our change in momentum is still 10, but it only takes half a second to slow down. The force now exerted is 20. The greater the amount of time, the less force it will need to change your momentum. If the change of momentum occurs over a short amount of time, the force of the impact is large, just like I showed you on the last slide. Because the decrease in momentum was the same, 10 each time, you have to have the same impulse, because remember, an impulse is equal to change in momentum. This means that for a change in momentum of 10, the impulse must be exactly the same. However, the impulse being the same does not mean the same amount of time or the same amount of force was applied. It means that the product of force and time were the same. If we keep the force small, the time gets extended. If we decrease the time, the force must be greater. When you extend the time, you reduce the force. A padded dashboard in a car is safer than a rigid metal one because you can sink into it. Your impact goes for a longer amount of time. Airbags save lives in the same way. To catch a fast-moving ball and not break your hand, you must extend your hand forward and move it backward after making contact with the ball. This, again, increases the amount of time the impulse affects the momentum of the ball. When you jump down to the ground, bend your knees when your feet make contact with the ground to extend the time during which your momentum decreases. This makes it easier on your joints. There's less force. A wrestler thrown to the floor extends his time of hitting the mat, spreading the impulse into a series of smaller ones as his foot, knee, hips, ribs, and shoulders successfully hit the mat. The impulse provided by a boxer's jaw counteracts the momentum of the punch. A boxer moves away from the punch. If a boxer moves towards the punch, then the time of impact is less and the force is greater. Likewise, a glass dish is more likely to survive if it's dropped on a carpet rather than a sidewalk. The carpet has more give, so the time it's sinking in to the carpet is greater. This results in a smaller force. A shorter time hitting the sidewalk results in a greater stopping force, which is why your bowl or glass might shatter. The last example is the safety net used by circus acrobats. This achieves the impulse needed for a safe landing. The safety net reduces the stopping force on a fallen acrobat by substantially increasing the time interval of the contact. Make sure you answer in your notes. When a dish falls, will the impulse be less if it lands on a carpet than if it lands on hard floor? Why? If a boxer is able to make the contact time 5 times longer by riding with the punch, how much force of the impact will be reduced? Here's your summary. What factors affect how much an object's momentum changes?